March 1945, on the east bank of the Rhine in Germany. Headman Klaus Bergman peers through his binoculars. On the opposite bank, American engineers have just started work. 12 minutes ago, he counted the soldiers. 6 men per panel. No cranes, no heavy machinery, just identical-looking steel panels. His calculations say it's impossible. Bergman is a civil engineer. When the Wehrmacht recalled him in 1943, he was assigned to military engineering. He learned quickly that war changes everything. You don't design for permanence, you design for function. A bridge needs to last just long enough for the army to cross, maybe a week. But even temporary bridges follow the same laws of physics. Load calculations, material stress, foundation stability. A 60-meter span requires support structures, and it requires time. Bergman has built 17 bridges in 2 years. Wooden trestle bridges in Russia, steel girder bridges in France. Each one took days, sometimes weeks, to construct. He has also destroyed 23 enemy bridges, blowing them up to delay the enemy advance by weeks. Time for German forces to regroup, to establish new defensive lines. Operation Plunder began 24 hours ago, the largest amphibious assault since D-Day. British and American forces have crossed the Rhine. Now they need bridges, heavy bridges that can carry tanks and supply trucks. Bergman knows the German calculations. Every Rhine bridge was destroyed during the retreat. To rebuild them, the Allies would need at least 3 weeks. That was the official estimate. 3 weeks for the Wehrmacht to consolidate defenses and prepare for the battle ahead. The entire German defensive strategy depends on those 3 weeks. Bergman looks through his binoculars again. 30 minutes since the Americans started. 4 modules are already in position. He opens his field notebook, sketching what he sees. Modular panels, steel construction, approximately 3 meters per panel. He closes the notebook, looks at his watch. 32 minutes. The 5th module slides into place. Bergman does the math. If they maintain this pace, they'll complete the bridge in under 6 hours. Impossible, but the bridge keeps growing. He observes for another 2 hours. The panels are perfectly identical, every single one. Same dimensions, same weight, same connection points. 6 men lift a panel and carry it into position. The holes align perfectly, no adjustment needed. 4 steel pins slide through the holes. A soldier uses a pneumatic hammer, 2 minutes total, and the panel is locked in place. Next panel, same procedure, mechanical precision. He times it carefully. 15 minutes per panel, from pickup to final pin insertion. A 60-meter span needs 20 panels. 20 panels at 15 minutes each equals 300 minutes. 5 hours. But what about supports? The Americans aren't building traditional foundations. They're using large steel base plates, placed directly on the ground. No waiting for concrete to cure. The vertical supports are the same panels, just rotated 90 degrees. The same holes, the same pins. Bergman understands now. The entire bridge uses one single standardized component. Horizontal spans use the panel flat. Vertical supports? Rotate the panel. Reinforcement. Stack the panels. Every connection uses the same pins. A soldier trained to assemble one section can assemble any section. Bergman thinks about his own bridges. Each was a unique, custom-designed project. They required detailed drawings and skilled craftsmen. The Americans have eliminated all of that. No custom components means no skilled fabrication. No unique designs means no complex drawings. They've turned ordinary soldiers into assembly specialists. Hour 4. The bridge is over halfway complete. Bergman checks his calculations again. 3 weeks for a traditional bridge. But this isn't a traditional bridge. This is industrial warfare. Hour 6. The bridge is complete. 8 hours and 17 minutes from the first panel to the final pin. The Americans don't pause. They immediately begin load testing. A jeep crosses first, then a 2-ton supply truck, then a 6-ton truck, fully loaded. The bridge absorbs the weight without visible stress. Then he sees the first Sherman tank, 32 tons of American steel. Bergman holds his breath. 32 tons on a bridge built in 8 hours. The Sherman rolls onto the first panel. The bridge holds. The tank reaches the center span, the point of maximum stress. The bridge absorbs the weight. The Sherman reaches the east bank. Bergman exhales. A second Sherman approaches, then a third. The Americans aren't testing anymore. They're using the bridge. He notices that for key stress points, they use double-layered sections, overlapping panels connected vertically. Double panels mean double capacity, 40 tons, sufficient for any vehicle the Allies have. For the next hour he counts the vehicles, jeeps, trucks, half-tracks, tank destroyers. The bridge handles everything. It's not a temporary bridge, it's a highway. Then he sees something 3 kilometers downstream. Another American engineering team. Another bridge. Same design, same panels, same assembly procedure. He understands now. The Americans aren't just building a bridge. They're building a network. Multiple crossing points, simultaneous construction. If the Germans destroy one bridge, 3 others remain. It's not engineering, it's logistics. He calculates. If each team builds a bridge in 8 hours, and the Americans have 10 teams along this sector, they can build 10 bridges in one day. The Wehrmacht spent 6 months destroying 23 bridges across the Rhine. The Americans can replace them all in 3 days. Bergman stares at that calculation. The math is correct. 3 days to rebuild what took 6 months to destroy. The German defensive strategy is obsolete. He returns to headquarters that night. The Americans completed 2 60-meter bridges today, he reports to the colonel. 8 hours per bridge. Load capacity, 40 tons. Can we destroy them? The colonel asks. Yes, Herr Oberst, but they will rebuild them in 8 hours. Silence. The colonel looks at the map, at the 23 red X's marking destroyed bridges. His entire plan is built around those marks. How many teams do the Americans have? Bergman replies, if they have 10 teams per sector, and 3 sectors, 30 bridges per day. They can replace every destroyed Rhine bridge in 1 day. The colonel sits down heavily. The defensive plan is obsolete. Bergman thinks about the Bailey Bridge. It's not just a bridge. It's a system that transforms construction from an art into an industrial process. The Americans didn't invent a better bridge. They invented a better way to build bridges. And Germany can't copy it. Not because the design is secret, but because Germany lacks the industrial capacity. The Bailey Bridge requires mass production of thousands of identical panels. Germany's factories are destroyed. It requires standardized training for thousands of soldiers. Germany's training system is collapsing. It requires a logistical system to distribute tons of steel. Germany's supply lines are chaos. The gap isn't technical, it's industrial. Industry wins wars. In his final report, Bergman writes, Germany's defensive strategy based on destroyed bridges is obsolete. The enemy can restore Rhine crossing capacity faster than we can destroy it. He knows it will be too late. The man who designed the Bailey Bridge, Donald Bailey, probably never saw combat. But he understood something fundamental about modern war. Speed matters more than elegance. Standardization matters more than customization. The Bailey Bridge became the most widely used military bridge system in history. Over 3,000 were built during the war, stretching over 1,000 kilometers. Some still stand today. The system Bergman observed that day represented the industrial advantage that decided the war. Not just courage or tactics, but production capacity, the ability to turn raw materials into functional systems faster than the enemy could destroy them. Thanks for watching. If you enjoyed this story, be sure to like, subscribe, and hit the bell icon for more deep dives into history's turning points.